Now we are going to learn about nitric acid. Nitrogen forms a number of oxo acids such as hyponitrous acid, nitrous acid and nitric acid. Among them, nitric acid is the most important. The molecular formula of nitric acid is HNO3. Now let's start our discussion with the laboratory preparation of nitric acid. In this method, equal amount of potassium nitrate and concentrated sulfuric acid are taken in a glass retort. They are heated to a high temperature, so nitric acid vapors are produced, which are then condensed in a receiver, which is further cooled by pouring water on it. You may question why they are further cooled by water. This is to prevent decomposition of nitric acid. We know nitric acid will decompose to form nitrogen dioxide at high temperature. Now let's move to the industrial preparation of nitric acid. On industrial scale, nitric acid is produced through Oswald procedure. In this process, the conversion of ammonia to nitric acid is done through the following steps. In the first step, oxidation of ammonia to nitric oxide takes place. Ammonia is oxidized by air at 800 degrees Celsius in the presence of platinum catalyst to yield nitric oxide. The second step is oxidation of nitric oxide to nitrogen dioxide. The nitric oxide is oxidized by air at temperature below 100 degrees Celsius to yield nitrogen dioxide. The third step involves the formation of nitric acid. The nitrogen dioxide formed is absorbed in water, is then converted to nitric acid in the presence of air. Now let's discuss the entire process involved in the manufacture of nitric acid. Mixture of dry air and dry ammonia in the ratio of 10:1 by volume is compressed and then it is passed into catalytic chamber. In the catalytic chamber, we have platinum rhodium gas. This gas is first heated to around 800 degrees Celsius electrically. From that point, no outside heating is required as oxidation of ammonia is an exothermic process. In the catalytic chamber, ammonia is oxidized by air at 800 degrees Celsius in the presence of platinum catalyst to yield nitric acid. The nitric oxide formed in the catalytic chamber contains little amount of nitrogen and some water vapors. They are then passed through heat chamber where they are cooled to around 100 degrees Celsius by advancing them through coolers. Then they are passed to oxidation chamber where the nitric oxide combines with more air and it gets oxidized to nitrogen dioxide. The nitrogen dioxide is then permitted to enter into absorption tower from the lower end. The tower is stuffed with quartz pieces and water is sprinkled from the top. Here, nitrogen dioxide is consumed into water in the presence of air to yield nitric acid. The aqueous nitric acid formed can be concentrated by distillation up to 68% by mass. Further concentration to 98% can be achieved by dehydration with concentrated sulfuric acid. Now let's discuss about the physical properties of nitric acid. Nitric acid is a colorless liquid that boils at 84.1 degrees Celsius and freezes to a white solid at minus 41.55 degrees Celsius. You might have noticed that the nitric acid stored in the laboratory bottles are yellow in color. This is because nitric acid will decompose in the presence of sunlight to give nitrogen dioxide. Laboratory grade nitric acid contains approximately 68% of the nitric acid by mass and has a specific gravity of 1.504. In the gaseous state, nitric acid exists as a planar molecule. Now let's discuss about the chemical properties of nitric acid. The first chemical property is its acidic nature. In aqueous solution, nitric acid behaves as a strong acid, giving hydronium ion and nitrate ion. The second property is the oxidizing nature of nitric acid. All metals, with the exception of noble elements like gold, platinum, rhodium, will react with nitric acid. Nitric acid oxidizes the metal. But if you consider the metals such as copper and zinc, which are insoluble in hydrochloric acid, but they dissolve in nitric acid, the reaction of these metals with nitric acid will differ with their concentration and temperature. In the examination point of view, these equations are very important. You have to memorize the balanced chemical equations. For example, they may question us, illustrate how copper gives different product with nitric acid. But some metals like aluminium, iron, cobalt, nickel and chromium are rendered passive in concentrated nitric acid due to the formation of their oxide layer on the metal surface, which prevents the nitric acid from reacting with pure metal. Now let's see what is aqua regia. Aqua regia is a yellow-orange liquid which is obtained by mixing concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. This aqua regia can dissolve the noble metals such as gold and platinum, but not all metals. The last chemical property that we are going to discuss is the reaction of nitric acid with nonmetals. Concentrated nitric acid also oxidizes nonmetals and their compounds. For example, iodine is oxidized to iodic acid, carbon is oxidized to carbon dioxide, sulfur to sulfuric acid and phosphorus to phosphoric acid. Now let's study about brown ring test. Hope you all remember this test we did in the laboratory to find out the presence of nitrate ion in the simple salt. We will just refresh the procedure. In one test tube, we will take the aqueous solution of the simple salt. That is, in specific aqueous solution of nitrate salt. And in another test tube, we will take the freshly prepared ferrous sulfate salt solution. Then we will be mixing these two salt solutions. Then we will take the concentrated sulfuric acid and we will be adding it along the walls of the test tube. If brown ring is formed at the junction of two layers, we will confirm the presence of nitrate ion. Now let's study the chemistry behind this brown ring test. This is important in the Viva examination point of view as well as the theory examination point. The Fe2 plus ions present in ferrous sulfate will reduce the nitrate ion, that is NO3 minus ion, to nitric oxide. This nitric oxide will further react with Fe2 plus ions to form a brown colored complex. These are the uses of nitric acid. Students, kindly practice these questions in your notebook.